This lesson is 1.3 inputs and ifs. And when I say ifs, I'm referring to if statements. Now, I think it's very important for students to learn how to get input from a user really early on because it allows our programs to be different every time we run them. Now, with getting inputs, right, we're going to start introducing this idea of streams or the standard streams. And you've already seen one of them. That's this one on the right. That is how we get input, and we've seen the insertion operator, although we haven't called it that yet. We've just called it an operator. But now that we're bringing in how to get an input, we really want to start using those official terminologies. So on the right, you're going to see this diagram here, okay? And we got this little cloud, which stands for a buffer, and a buffer is a temporary place to store data as a go-between, okay? And that go-between is our program and where we're trying to output it. So if you can see in green here, we start where we have some variable or data that we want to print, and we insert it into the cout buffer, hence why we call it the insertion operator. And it, directs us towards cout. Once it's in cout, it can be taken, right? Because it's a buffer, it's a go-between, it's a temporary place. It can be taken by something else, and here that's going to be our console, where the message is printed. Now we're going to do cin, which is still using a buffer, but it's the opposite process, okay? We have this console area. It's where you run your programs, where you want to be able to type something in, and you type it in here, and it goes to the cin buffer, and there we use the extraction operator to extract from cin to our program, okay? So all three of these have very similar things, right? But you need to really follow those arrows, right? The extraction operator is pointing you to where things are going from the buffer to the program, and the insertion operator is taking us from the program to the output, okay? Now down at the bottom, which that looks like it's being covered now, you can see that we also call this standard in and standard out. And you can see an example for each one, right? Still using STD, 2 colons, but this time we use cin, the extraction operator, and then and then the variable we want to extract it to. Which standard out was the exact opposite, right? We gave a message and we inserted it into cout, and we could have done that with the new line escape sequence, or we could have done that with endl at the end, okay? Now this endl was how we flushed this buffer, okay? This being that buffer, right? We flushed everything out. We're gonna also learn how to flush the standard in, and I also wanna mention that there is a third standard stream it's called standard errors, but we're not gonna be going over that one in this video. So what we're going to do next is we're just going to cover the basics here. We are going to take these a little bit deeper, but how do we just get some input and how do we print that out? So we're in our program now. It's called input.cpp, and that CPP lets us know it's a C++ file. We have our IOStream header that we're bringing into our program. We have our main function that's returning 0 at the end for a successful run, okay? And we're just going to do some very simple stuff, right? I'm going to tell the user, I'm going to ask them to enter in a number. So enter a number. I'm going to put a colon like that. And then that way we can have a little bit of a space. And I'm not going to do the endl. I'm not going to flush the buffer here because that also gives us a new line. And I want the input to just show up right at the end there in the console, okay? And since I'm asking to enter a number, I'm going to create a primitive data type for a number. Now, I gave it a default value of 0. I know a lot of the times when you just declare an integer, you see a default of 0, but a lot of other times you could also just see a random value when you only declare. So make sure to give it something, okay? And now I want to use that X to take the number from the user and store it in X. So let's use the cin. And we use the other operator, the extraction operator, which I think I called this one the extraction earlier. That's the insertion. This is the extraction. and we store it in X like that. Now for good measure, to confirm that we got the right number, let's print it out. So you entered, and then let's add another insertion operator and do that. And then let's flush the buffer. Okay, so if all works here, we should see, we should be able to see us entering a number, it going in place of X, and then us printing it out. So let me run this in our terminal. I'm going to compile it with G++. And that was all good. I run it with a.out. So enter a number. I'm going to enter 10, and you entered 10, right? So that did work. And we saw that X was 0 before, so everything's on the up and up. But let's see what happens when we run the same program. And let's enter high, right? I know we said enter a number, but does that mean we have to? And I enter high, and a 0 still shows up, which was our default value for X. This is why we're going to go much further than just, oh, here's C in. Okay, I see this a lot. People just are, they show students what a C in is and go, cool, you can get input, right? But then they never show those nuances early on that, how do we get the right type, right? Because C++ is a statically typed language, right? So we need to specify these things. So we're going to go over that in the next slide. All right, now in order to kind of protect what inputs we're getting to make sure we're getting the right data types and our programs work, we're going to need to learn about if statements. And so we are going to kind of dive into them pretty deep. We're not going to show everything about if statements in this lesson, but we're going to show a lot. So we have our first example up here, right? And an if statement basically tests if a Boolean statement is true or false, and then runs a block of code if it's true, and then doesn't run it if it's false. So this is our decision making, the very basic building blocks of deciding, do we go left or do we go right? Okay. Now, of course, a single statement, if true is not going to, or if false is not going to be enough, right? So we have if else statements. So we can say something like, if this Boolean statement is true, run this. If this Boolean statement is not true, that's where our else will run. So code to run if false. Okay. So it's if this or that. And the cool thing about the else is it guarantees a run. If the if statement is false, then the else statement will run no matter what. If the if statement is true, the else statement will not run, but one or the other will when you do this. Now notice how they're linked together. In this first one, we had an open brace and a closed brace for everything inside that would run if this if statement was true. And we do the same thing, but the else statement here comes right at the end of the other brace. And that's important. You can't have anything in between them because they need to be linked. And of course, we can take this another step further with an if else statement. Okay, and this allows us to put more than one condition. And we can chain as many else ifs as we want. I actually don't even think there's a limit. You can have 100 of them if you want linked together for any possible condition. But if you needed 100, you should probably rethink your approach here. So this one would be, if this statement is true, run this. If it's not, let's look at the next else if. Okay, else if this statement is true, run this one. If not, go all the way down to the else statement, which will run if all the ones above it are false. Now this brings in another important concept called short circuit evaluation. And this is the evaluation of an if statement. Evaluation of if statement ends when a true Boolean statement is found. The rest will not be looked at. So what we mean by this is if this first if statement is true, then the computer's not even going to look at these other two. Okay. So even if this one would also be true, it doesn't matter. Once it hits a true statement, it jumps out of this block, this if else block. Okay. So keep that in mind when you're organizing your statements. Now, how do we use these with our input? Okay. So you can see that we can use an if statement to check if we had a stream successfully put a value into Y. So notice how right here we put the statements standard cin. We use the extraction operator to y. If this works, meaning the data types are this, appropriate, then, we can move to the next step and run stuff. If not, right, we're going to get an error, right? And that means that this would be false. We need to clear the error flags from cin, and then we need to ignore a bunch of the stuff in the buffer. All right, essentially get rid of everything in the buffer. We use 10,000 here to just say that we're clearing 10,000 characters up until we see an escape sequence for a new line, which this should be the end of every buffer, would be a new line thing. So when we find that, we know we're at the end, okay? This starting to look pretty complicated, okay? And so let me just talk about this one more time, all right? This right here is checking if the input worked, okay? Meaning that y was an int. If y here was a string or a character or a Boolean, something like that, right? This would be false, and we need to make sure that we kind of reset up cin so that it'll work again, all right? Which is very important to do. This is not something that's normally shown this early, but I think it's very important because that's going to be the most common errors when getting input is user entering in the wrong data type. So you need to know how to deal with it. So let's jump into let's just jump into a live code example here of what this would actually look like and how this would run. Okay, so we're back to this program, right? And we saw here that we had this error. You entered 0. So I'm going to show you what happens when you don't clear the buffer, when you don't clear and reset up the flags for cin, and then I'll show you what it's like when you do clear it, okay? So this statement right here, this standard cin, needs to be in an if statement now, just like this. Hold on. And then instead of a semicolon at the end, we have an open brace, and this would be the code inside. So we're saying if this works, okay, run this code. So here I'm going to say, well, you know what? We already have that, right? So we know that it was entered successfully. And let's add that you entered, X successfully. Like that. Okay, perfect. And then after this, I'm going to do it again. Okay, I'm going to get input from the user again so you can see what happens when you don't clear the flags for an error. So let's do this. Let's ask the user again. Enter another number. Put that space there. And I'm going to create an arbitrary variable for it and then use it without an if statement. Use cin without an if statement and send it to y. And then I'm going to copy and paste this right here. Put it there, and I'm going to change x from y, or x to y. So to recap here, right? Our first one here, we're doing it kind of the right way to check if we have the right data type. And then the one after that, we're doing kind of the regular way. All right. So let's run it, or we got to recompile. Well, first I got to save my program. Then I need to compile it. Everything looks good there. I would have gotten an error, right? And I run it, so I'm going to enter number 5. And you entered 5 successfully, so I should probably add a space there so that I can see an actual space for that 5. And then I, get another chance, put a 4. Everything looks on the up and up, right? Okay, let's do this again, but let's put the wrong data type. So I need to recompile because I put those spaces. And I run it again, so enter a number. I'm going to put high this time. And you can see enter another number, you entered 0. So I didn't even get a chance this time to do it the second input because we messed cin up by putting the wrong data type in, okay? So this is a problem, right? So what we do is we add in this else statement, and we do this to clear cin, right? So I'm going to go cin dot clear, okay? And I know that's kind of confusing. It makes you feel like you're clearing the buffer. That doesn't clear the buffer. That just resets the error flags where, those are signs to see in. Am I still working? Am I not working? Okay. And then we do see in dot ignore, and we send it a 10,000, which is just an arbitrarily big number to ensure. Right now, we're not entering 10,000 characters. I mean, we could have chose 100 characters, but then if you have something more than 100 characters, it would not be ignored, right? So we're going to put 10,000. And then notice single quotes around this because that's a single character, which I could have been looking for a space to stop at, but I want to stop at the end, which would be the new line character. Okay, like that. Now when I run this, which I need to recompile, I run it again. I'm going to mess it up. I go hi, but look, now I get that second chance. Enter another number, which I can put 4. You entered 4 successfully. This is absolutely essential to recover from errors, okay? And users are going to make errors. They did not write the program that you wrote, and so they're going to find every little thing wrong with it. So you need to know how to do this, okay? Now, we just kind of threw in if statements, and so we're going to kind of dive a little bit more into them now with relational operators and short circuit evaluation so that you can use if and else statements more in your programs. Here we have our relational operators, and you can see that there are 6 that we're going to be talking about. The first one is equal to, which is represented with 2 equal signs next to each other, which is not to be confused with a single equal sign, which is the assignment operator. This tests if x is equal to y. That is a true or false statement. So if it is true, we know that code will run. If it is false, this code will not run, okay? Now, same thing here, except for this is not equal to, which is an exclamation mark followed by an equal sign. So it's asking, is x not equal to y? So if x was a 3 and y was a 4, that would be true. X is, 3 does not equal 4, so this would run. Then we have x is greater than y, so something like 4 is greater than 3. I know I'm using a lot of numbers here because that's a lot of what we know how to work with at this point. We have less than, x is less than y. We have greater than or equal to, and then we have less than or equal to. This is going to help us start to make decisions in our program based off of what the user says. So we can start asking the user things like, hey, enter in a 3 if you want to do this. Enter in a 2 if you want to do that. Or, the sky is the limit so far with just thinking about integers, okay? Now, let's see, what's the next slide? Okay, this is going to be an example on relational operators, but we're also going to talk about short circuit evaluation. We're back at our previous program, and I'm going to get rid of this second input, and we're only going to use the first one. So we're asking for a number, checking if it's correct, right? Making sure we have the right data type, and then let's use some if statements with that and see what we can do. So I'm going to say if x is greater than 10, and I'm using my braces, I'm just going to print out, let's print out, x is greater than 10. Okay. And let's clear that buffer. Awesome. And let's give this, save it, compile it, run it. So let's go and let's do 15. Okay, boom. X is greater than 10. 15 was greater than 10. That works. Let's run it again. Let's choose 10. So we entered 10 successfully. We got that, but nothing else happened, right? Let's run it again. Let's do 5. Okay. Same thing. Our program is working just fine. But generally, when you have an if statement for something, you need to, do this or that, right? An opposite. So here, we're going to run else. Because if it's not greater than 10, we want to print something out. And I'm going to say x is less than 10. The opposite. Like that. Let's give it a compile. Give it a run. Enter a number. Let's try 15. Everything works. 10. Nothing happens. Or no, excuse me. Sorry, x is less than 10 printed out, which we know is false. And then let's run 5, which worked. X is less than 10. So what happened here with this, X is less than 10 printing out when we chose 10. This is called a logic error. We wrote a program that works just fine, but logically it's not working, right? Because we didn't put in a condition for when X was equal to 10. So let's use another else if. So else if X is equal to 10. Let's do this. Okay. And let's put something for that. So let's print out X is equal to 10. So now we have every single instance here. Okay. So let's give this a compile, give it a run, enter in the 10, boom, X is equal to 10. So we've covered all of our bases here. Okay. Using an if, else, chain, as I like to call them. All right. Now, short circuit evaluation is telling us that as soon as we run down this and find a true one, our program is going to jump out of this block. So if this first one is true, these two will not even be looked at because only one of these should ever run. And I'm going to show you a prime example of this. I'm going to change this to be X is greater than 5. Okay. And if you think about that, right, any number that is true here is also going to be true here. If I put 11 for this first one, 11 is greater than 5. That should also be true. So a lot of people think that they're both going to print out. I'm going to compile, give it a run. Let's enter 15. And we see X is greater than 10 print out, right? Which was a single thing. Maybe you were expecting, both of these to print out, which I should have changed this to, right? To say X is greater than 5. But only one thing is going to print out there. All right. And that's that short circuit evaluation. If I change this, if I flipped these around, this first one would catch it always, right? So let's do this. Let's change this to a 5. Make that a 10, and let's change this meaning here. X is greater than 5, and let's just go X is greater than 10. Give it a compile, give it a run, and let's enter 11, which would be true for both. We can see we only get X is greater than 5. We now kind of, again, have a logical error here, right? This statement here should never run because this first one will always be true and never allow us to see that one, right? Like if this first one is true, this second one has to be true always, right? So we have another logical error that you need to be careful of. And logical errors are going to be your, the hardest ones to overcome because the compiler is not able to catch those types of things. And a lot of the times it's hard to figure out where they come from, okay? But you'll get better with them over time. So this is kind of bringing us close to the end of the video here where you need a quick code to practice what you're learning, okay? You always have to try and code in order to learn code. You can't just watch a video and absorb it. You have to type it in. So the first thing you need to do is create a program where the user enters in a grade they received on an exam. And you tell them what letter grade that would be, okay? You need to use standard cin, and you need to use, an if, else, block or chain, okay? And if they enter in a number greater than 100 or less than 0, tell them that's not possible, right? You're not getting 180 on this. You're not getting 1,000. You're not getting a -5. So you need to include conditions where, in those relational operators to check for that. And then before checking which letter grade they received, you should use a separate if statement to make sure the user gives the correct input type. And that's what I showed you with that, clearing the cin flags and clearing the buffer to make sure that it's available.